Welcome to Distributed Systems course. So in this lecture that we will understand one simple consensus algorithm called Paxos. So in the previous part of this videos that we saw what is consensus and how it is used in distributed systems to agree on some state or value. Here we will understand Paxos. It is one of the consensus algorithm protocol used in distributed systems to agree on state or value. So we will see here how it works. Paxos. So here, we saw what is consensus. So it's a consensus in algorithm in a distributed systems used to agree on some state or value. Let's consider this with a simple example. We have multiple nodes. And we have a client which makes a request. Now let's call these are 5 nodes. Let's say that this is a node 1, n1, and this is an n2. This is a node 3, node 4, and node 5. Now we have a distributed system that is made up of 5 nodes, and so the client is sending the request to some nodes. So let's say it's sending the request to node 1. Now node n1 has to decide some value. For example, here we have a value called 50, and this value should be agreed between all the nodes. So this is what is consensus. So it will be sent to all the nodes. Now all the nodes should accept this value. So the value will be chosen. This 50 is the value will be chosen. So here we are considering the value 50. It could be anything in the real world. For example, in literal action, it could be node ID. So main thing to understand here is that consensus, how consensus works in Paxos. So let's say the client makes a request to n1. It's called proposer. Proposer is the node that takes care of all the orchestrating things on how to agree a value. So it will first before sending the request 50, it will first send down sequence number. Let's say that some sequence number or some number. Let's say it's n. The n will be sent to all those nodes. This is what is called prepare phase. So there are 2 phases, prepare phase and accept phase. In the prepare phase, it will send the request to all the other nodes. For example, here it will send to all the other nodes. So what it will send? It will send the number n, send to all the nodes. Number n, it's a sequence number, kind of like a number. So we can say it is a number. Now the number is received. This is a prepare phase. Once the number is received by all the nodes, now this is a promise phase. What it will do is it will check the number, all the nodes, and now here we are sending the request to all the nodes. If you want the 4 nodes to agree on something, then the majority will be sufficient, which means that if the 3 nodes agreed on that value, that will be enough for us to choose the value. Here we send the data to all the nodes. Now all the nodes that receive the value, receive the number here, will check if this is the higher number so far it has received. If it is, then it will reply with a promise. It makes a promise to the request that n is prepared. Now the second phase is the accept phase. Once the n is preferred, it will send the actual value with n. Here n comma 50. Now the n comma 50 is sent to all the nodes that was sent to the prefer phase, right? Then again, if the n is higher, if it is not already been promised higher than this one, for example n is 50, the promised one, if there is a higher value of n is promised, then it is rejected. I mean, it is not processed, it is ignored. Otherwise, it will return the chosen value, accepted. For example, 50. Here, the accept request. First, it will make the prepare phase send the request, prepare request. Then the promise is received from all those nodes. Then accept phase, accept is sent, then accepted is received. Here, accepted is once it is received, that it will check the core. For example, there may be node failure in certain cases, so we have to check the majority of the nodes agree on this value 50. If those agrees on the value 50, then we have value 50 is the chosen one. The value or state is agreed between all those nodes. Now we have a consensus algorithm that works. There are other failure cases that we have to consider here. For example, we saw that when the request is accepted, so if there is any promise that is higher than n, we will reject the accept. So the same way that when the promise is made, if it is already been accepted, then instead of n, then the value will be sent n1. So this is how we have a two-phase. So the communication between two phases somewhat it may look like complex, but these two phases works like this, and to agree on some stated value. Now this is how Paxos works. It is used in DynamoDB and some other distributed systems. Even in Cassandra, it will work for a lightweight transaction. It is used for lightweight transaction. Cassandra is a distributed database. This is what is called Paxos consensus algorithm used in distributed systems. It works in two phases to agree on some state or value. Once it is done, so we have a chosen value. So it could be something else. For example, it could be anything. For lead election, it could be some value to elect a leader. So all the nodes can send a request to all the other nodes. Once again, how the Paxos works. So the proposer, it has a two phase, prepare and accept phase. So the prepare phase, it will send the request. Proposers send the request to all the acceptor. So these nodes are called acceptor. And once the acceptor accepts the request based on the number, and if it is higher, then it will return the promise. If it is already been accepted, the number, then it will return the value. For example, for the number and the value is already accepted value, previous value. So once the proposer that received the promise, this is also called learner in Paxos. Once it is received the promise, then for the sequence, for the number, then it will make the request accept request. For example, here we want to agree on a state called value 50. It will send the request to the nodes again. So the nodes that receives, the acceptor that receives this request will accept this value 50 and return the response. If the majority of the nodes agree on some state, the learner will decide the value 50 and decide the chosen value 50. Now the failure case, for example, here when the accept request comes, that if the promise is already changed for some reasons, then the request is rejected. So there are multiple failure cases. In those cases, the request may be rejected or network failure. In those cases, that learner will decide whether to accept the state or agree on this value based on the quorum. Quorum here is majority of the nodes should agree on the state, return the correct response. So this is a recap of Paxos. So this is how the Paxos works in the distributed system.